Hello, welcome to my YouTube channel. In this video we are going to apply the laws of indices to solve the following set of equations. So without further ado, I would like us to dive right into solving the problems. Now, in question 1 here, we have that x raised to power 1 over 2 is equal to 5. This is a very simple case. So what we are going to do simply in this type of equation is to, this is also the same as 5 raised to power 1. So we're going to look for what to use to multiply the power of both the left and the right hand side to make it 1. Okay? We're going to look for what we are going to use to multiply the power of the variable we are interested in, which is x, to make it 1. And to do that, we say x raised to power 1 over 2. What we can use is the reciprocal of this. So that is 2 over 1. That is equal to 5 raised to power 1 times 2 over 1. So this will cancel this. So what we have here is x raised to power 1 is equal to 5 raised to power 1 times 2 is obviously 2. So that is to say x is equal to 5 raised to power 2 is 5 times 5, which is 25. So that will be 25. That's for that. The question 2 very quickly says that x raised to power minus 2 is equal to 36. Now we know that there is a law of indices that says that negative index inverse the base. So this is 1 over e raised to power n. So we're applying that law here to invert this. So we have 1 over x raised to power 2 is equal to 36. So, and this 36 is named as over 1. So now we can now take the inverse of both sides. Okay, so that would be x raised to power 2 over 1 is equal to 1 over 36. So what would that give us? This would mean this is also the same thing as x raised to power 2 over 1 is the same thing as x raised to power 2, and that will be equal to 1 over this 36 is the same thing as 6 raised to power 2. So, and that will give us, now we can bring this one up. So that will give us x raised to power 2 is equal to, when that 6 raised to power 2 comes up, it becomes negative back. So we now look for what to multiply the variable, the power of the variable we are interested in, which is x, to make it 1. And obviously, what we can use to multiply 2 to make it 1 is 1 over 2. That is reciprocal. So that will be x raised to power 2 times 1 over 2 is equal to 6 raised to power minus 2 times 1 over 2. So that will give us this cancels this, so we have x is equal to, this cancels this, we have 1, so that will be 6 raised to power minus 1. So of course negative index again inverts the base, so that will, therefore x will be equal to 1 over 6. So that is for that. So now question number 3 very quickly is saying that x cubed is equal, x raised to power 1 over 3 is equal to minus 4. What will be the value of x? So now in solving this, very straightforward, we are going to look for the number we are going to multiply the power of the variable we are interested in, which is x, so that it becomes 1. So what we are going to use to multiply 1 over 3 to get 1 will be 3 over 1. So multiply, you do that for both sides. The power of minus 4 is 1. So see, this is x raised to power 1 over 3 times 3 over 1 is equal to minus 4 raised to power 3 over 1. So that is this 1 times 3 over 1. So this 3 cancels this 3. So what you have is x raised to power 1 is equal to minus 4 raised to power 1 times 3 is 3. So this minus 4 raised to power 3 means minus 4 times minus 4 times minus 4. So that is x is equal to minus 4 times minus 4 times minus 4. So, of course, when I'm multiplying numbers, we multiply the signs in front of them. So, minus times minus times minus, minus times minus is plus, times minus is minus. So, therefore, x will now be equal to minus 4 times 4 is 16, times another 4 is 64. So, that's minus 64. That is for x. Then, let's look at the fifth question very quickly. For the fifth question, okay, the fourth question, we are told that x raised to power 3 over 4 is equal to 3 raised to power, could this be 3? Okay, 3 over 2. So now, to solve this, the same thing, we are interested in x, so the power of x is not 1. So to make it 1, we multiply the power of x by the reciprocal of it, so that we can get 1. So whatever we use to multiply it, we use to multiply both the power on the right hand side. So now, clearly reciprocal of 3 over 4 is 4 over 3. So we'll do that. We say 3 over 4 times 4 over 3. That will be 3 raised to power 3 over 2 times 4 over 3. So now, we do our cancellation. Cancel this 4, go into this is 4 into 4 is 1, 3 into 3 is 1. So everything here is 1. So that is x raised to power 1 is equal to now 3 into 3 is 1, 2 into 4 is 2, 1 times 2 is 2. So that will be 3 raised to power 2. So therefore x will now be equal to 3, x raised to power 1 is x. It's equal to 3x, 3 raised to power 2 is 3 times 3, and that is 9. So let's look at question number 5. Question number 5 is saying that 25x raised to power 2 over 3 is equal to 1. Now, in this case, what we are going to do, we are interested in the variable x. So what is standing close to the variable is 25. So we're going to divide both sides by 25. In doing that, we say this divide by 25, this divide by 25. So 25 cancels out 25, so we are left with x raised to power 2 over 3 is equal to, now this is 1 over 25. We can write this 25 as 5 raised to power 2. So if you bring this up, it becomes 5 raised to power minus 2. So that is x raised to power 2 over 3 is equal to 5 raised to power minus 2. So what we do next is to look for a number that we can use to multiply the power of the variable we are interested in. That we can do, we multiply both sides. Okay. Now, what we can use to multiply the power of this variable, the power of the variable, the unknown variable, is 3 over 2. So we just go ahead and this is x raised to power 2 over 3 times 3 over 2 is equal to 5 raised to power minus 2 times 3 over 2. So now 3 into 3 is 1, 2 into 2 is 1, so that is x raised to power 1 is equal to 5 raised to power 2 into this 2 is 1, that is minus 1. Minus 1 times 3 is minus 3. So, and of course, negative index inverts the base. So this will now become x will be equal to 1 over 5 raised to power 3. Of course, 5 raised to power 3 means 5 times 5, 25 times 5 again, which is 125. So that is to say x will be equal to 1 over 1, 2, 5. So let's look at the last question, which is question number 6. It says if we have 3x raised to power 3 over 5. If that minus 81 is equal to 0. So in doing this, we move the constants to the right hand side. Okay, we collect like terms. All the terms containing a variable x will be this way. Then the constants, those that are not having x, we move to the right hand side. Of course, if this minus crosses equality sign, it changes to plus. Or we can say better still, we add 81 to the left and the right hand side of the equation. So whichever way you do it, you come up with the same result. So this will be 3x raised to power 3 over 5 is equal to, when this goes this way, becomes 0 plus 81. Okay, so of course 0 plus 81 the same thing as 81. So now we divide both sides by 3, because 3 is standing close to the unknown variable we are interested in. Divided by 3, divided by 3. So 3 into 3 is 1. So we are left with x raised to power 3 over 5 is equal to, now 3 into 81 is 27. So, and of course this is x raised to power 3 over 5 is equal to, 27 can be written as, 27 is the same thing as 3 times 3 times 3. So that is 3 raised to power 3. So now if you look at the variable has a power of 3 over 5. So we multiply the powers on both sides by the reciprocal of the variable. So that will be x raised to power 3 over 5 times 5 over 3 is equal to 3 raised to power 3 times 5 over 3. So now this 3 going to 3 is 1. 3 going to 3 is 1. 5 into 5 is 1. So everything here gives us x raised to power 1 is equal to 3 raised to power, what is left here is 5. So 3 raised to power 5, the same thing as 3 times 3, 9 times 3, 27 times 3, 81 times 3, 243. So that will give us x is equal to 243. So this is pretty much how you can apply, one of the ways you can apply the laws of indices to be able to evaluate equations like this. So please, if you find this video useful, I would like you to like it, comment, and click on the notification bell icon below so that you get notified each time I upload a video like this. Of course, this is going to be part 5 of the application of the laws of indices to solving equations like this. Then again, do not forget to subscribe, press or click on the subscribe button below to subscribe to this channel. So I will catch you in the next one. Bye.